I hope that you guys are doing well. In today's lecture, we'll talk about flip-flop excitation table. This is the continuation of our previous lecture. In last lecture, we have talked about the flip-flop, and we know that the flip-flops are the memory element that can store 1 bit information, and furthermore these are used in sequential circuits. And also we have discussed the difference between flip-flop and latches. The flip-flop operate or work on clock pulse. These could be positive edge trigger or negative edge trigger flip-flop. As the positive, if suppose the flip-flop is positive edge trigger flip-flop, then uh, as the positive edge trigger comes, it execute the input and give the output. So furthermore, the output or the next state or the output of the flip-flop depend upon the present state and the input of the flip-flops. Also further, the latches are uh, also like a flip-flop, but these have no clock pulse. These just depend on the input, also the present and also the present state of the flip-flop and the inputs. So as the inputs are changed, so it effect on it execute and it gives the output. Okay, furthermore we have talked about the uh, truth table or truth table of the flip-flop, and also it is known as the characteristics table. And further and now we will drive the excitation table by using the truth table or excitation table of the flip-flops. Okay, first there were 4 types of flip-flop as we have discussed. One was RS flip-flop, other was D flip-flop, and JK flip-flop, and T flip-flop. Okay, now let us start with the RS flip-flop. The RS flip-flop, graphically we represent it this is the clock pulse. It has 2 inputs, those are R is for reset and S is for set, and it has 2 output, Q and Q complement. RS flip-flop. Okay, now the truth table is, we have a present state, x of t, and it has 2 inputs, those are set and reset, and the next state is q of t plus 1. If we have present state is 0, set is 0, reset is 0, then the next state would be 0. For 0 0 1, present state is 0, set is 0, reset is 0, reset is 1, so the next state would be 0. As we have already learned how the state is changed by using the circuits of RS flip-flop. So here when set is 1, it change the uh, it, now in this case the next state would be 1. When set is equal to 1, the next state is 1, whatever is the present state. Suppose if present state is 1, then it will remain 1. If present state is 0, then it will change to 1. When both set and reset are equal to 1, in this case we have indeterminate form and we never use this form when both set and reset are equal to 1. Next, when present state is equal to 1, set is equal to 0, reset is equal to 0, then there will be no change. The present state will remain same. Next, we have present state is equal to 1, set is equal to 0, reset is equal to 1. So when reset is equal to 1, the next state would be equal to 0. So here it would be equal to 0. Present state is equal to 1, set is equal to 1, reset is equal to 0. In this case, the next state will remain equal to 1. When present state is equal to 1, next state set is equal to 1, reset is equal to 1, the rest next state would be indeterminate. So we will not use reset and set simultaneously equal to 1. So this is the truth table. Now from using this truth table, I will derive the excitation table. Keep in mind that excitation table is very useful for you guys to design the sequential circuit, as well as in future and next few lecture you will see you will design the counters and some sequential circuits. So these excitation table are very important. So here I will derive the excitation table for RS flip-flop. So how excitation table you guys will use, you have a given present state and next state and you have to decide the inputs. So suppose you have a present state is q of t, next state is q of t plus 1, you will be given present state and next state when you will design some sequential circuit, and you guys have to decide what would be the inputs. So here the inputs are set and reset. When present state is equal to 0, next state is equal to 0, you can see in this truth table where the present state is equal to 0 and next state is equal to 0, then the inputs are set and reset are equal to 0. Here the present state is equal to 0, next state is equal to 0, set is equal to 0 and reset is equal to 1. So here we can say that the set is always, in this case set is always equal to 0 and reset could be equal to 1 or equal to 0. So I will plug in don't care condition here. So we will use a don't care condition wherein you have two options, either the input is could be a 0 or could be 1. So next, when present state is equal to 0 and next state is equal to 1, in this case you can see here this is the I'm using a red line here, present state is equal to 0 and next state is equal to 1. In this case, set is always 1 and reset is equal to 0. And next you will see when the present state is equal to 1 and next state is equal to 0. So in this case you can see that, see here, the present state is equal to 1 and next state is equal to 0. There is only one possibility here. In this case, set is equal to 0 and reset is equal to 1. When the present state is equal to 1 and next state is equal to 1, here you can see the present state is equal to 1, next state is equal to, in this case present state is equal to 1, next state is equal to 1. Then you have reset is always 0 in this case, and set could be a 1 or 0. So I will plug in a don't care condition here. So this is called the excitation table for RS flip-flop. Excitation table, and you guys have to keep it in mind while designing some sequential circuit. So this table is very important for you guys for designing purpose. Now let us talk about JK flip-flop. Now in JK flip-flop, I will replace the inputs with J and K. So in case of JK flip-flop, I have input J and input K. This is the clock pulse. So you have two inputs, J and K. Present state is Q of t and next state is Q of t plus 1. Present state is 0. J and K is equal to 0. So here when present state is equal to 0 and J and K are equal to 0, then there will be no change. The next state would be the same as the present state. So I will incorporate here 0. When the present state is equal to 0, J is equal to 0, K is equal to 1. In this case, the next state is equal to 0. When the K is equal to 1, the next state always would be equal to 0 when K is equal to 1 and J is equal to 0. When J is equal to 1 and K is equal to 0, the next state would be 1. You always keep in mind, when J and K both are equal to 0, then the present state, next state would be same as the present state. When J and K are equal to 1, then the next state would be the complement of the present state. Now here you can see that j is equal to 1, so the next state, and k is equal to 0, next state is 1. Here you can see that the j and k are equal to 1, so the next state would be the complement of the present state. So I will incorporate or plug in 1 here. When the present state is equal to 1 and j and k are equal to 0, so there will be no change. Next, present state is equal to 1 and j is equal to 1, sorry, present state is equal to 1, j is equal to 0, k is equal to 1, so the next state would be 0. When j is equal to 0 and k is equal to 1, next state would be equal to 0 always. So here present state is equal to 1, j is equal to 1, k is equal to 0, so the next state would be 1. When both j and k are equal to 1, the next state would be the complement of present state, so here I will plug in 0. Now from this table you can see that when present state is equal to 0, next state is equal to 0, what should be the input j and k? So here j and k, j is always 0 when present state is 0 and next state is equal to 0, here you can see, and k could be zero or 1, so I will plug in j is equal to 0 and k is a don't care condition. When present state is equal to 0 and next state is equal to 1, so in this case j is always equal to 1. J is always equal to 1, and what should be the value of k? K could be a 1 and could be a 0 as well as. So when so I will plug in don't care condition. So here present state is equal to 0, next state is equal to 1. Here present state is equal to 0, next state is equal to 1. So let me use some different, okay. So here the present state is equal to 0, next state is equal to 1, j is always 1 and k is a don't care. So when present state is equal to 1 and next state is equal to 0, you can see here, and this condition here j is a don't care and k is always equal to 1. Wait, when present state is equal to 1 and next state is equal to 0, you can see here this condition, and this j is a don't care and k is always 1. When present state is equal to 1, next state is equal to 1, so here j could be a 0 or j could be a 1. Present state is 1, next state is 1. Present state is 1, next, so j could be a 0 or 1, so I will use don't care, and k is equal to 0, always 0. So this is the characteristics table, excitation table for excitation table for JK flip-flop. Now let us talk about D flip-flop replace these tables. So in case of D flip-flop, we have one input, so here we have one input which is D. And next state is Q of t plus 1. So when present state is equal to 0, input is equal to 0, the next state is equal to 0. So the next state always, in case of D flip-flop, the next state always depend on the input. So here when input is equal to 1, present state is 0, next state would be equal to 1. So when input is equal to 1, when input is equal to 0, present state is equal to 1, the next state would be equal to 0. When present state is equal to 1, input is equal to 1, the next state would be equal to 1. Now let us talk about excitation table. When present state is equal to 0, next state is equal to 1. So in this case the input would be equal to 0. So when present state is equal to 0, next state is equal to 1, input is D. Whenever the next state is equal to 1, the input would be equal to input would be equal to 1. So here the input is equal to 1, here the input is equal to 1. So this is the excitation table for D flip-flop. Now let us talk about T flip-flop. It has one input, so I will replace D with input T. So here the present state is equal to 0, and this is the present state, this is the next state. When the present state is equal to 0 and next state and t is equal to 0, it is also known as a toggle flip-flop. So the toggle, how it toggle, if the input t is equal to 1, then it will toggle. If the present state is equal to 0, then it will toggle to 1, and if present state is equal to 1, then it will be changed to 0. So here the t is equal to 0, so the present state would be next state would be same as present state. Here t is equal to 1, so that it will toggle, the next state would be equal to 1. So here t is equal to 0, the next state would be same as present state. Here t is equal to 1, so the next state would be equal to same, so the next state will be changed, so next state would be equal to 0. And now let us talk about its excitation table. So when present state is equal to 0, next state is equal to 0, what should be the input? It must be 0. When present state is 0, next state is equal to 1, so the input should be 1. So here present state is equal to 1, next state is equal to 0, so the input must be 1. there is no change in this case. When in present state is equal to 1, next state is equal to 1, so the input would be equal to 0. So this is the excitation table for T flip-flop. You guys will keep in mind this excitation table. These excitation table would be very useful to design the sequential circuit. So hope you guys will concentrate on this lecture. Okay, thank you. That's it. Next we will see the designing of sequential circuits. Thank you.